You are currently the only person in this conference.
What happened, Shahid sir? Ramesh Raja, what happened actually? अरे विजय आदिला तीसरा earthquake. Okay. Is it of high intensity? Is it high intensity, Ramesh? Oh, 6.6. More than 6 is a more than 6 means it is a high intensity only, usually. So is there any effect is there any buildings affected? Okay. I think, see, actually, what happens with earthquake is whenever there is landslides or whenever there is melting of snow, whenever there is tectonic plates or anything, there can be various reasons for the earthquakes. It's not like anything. Okay, okay, okay. It was in the morning or evening? It was like in the early morning, 11 p.m. Okay, okay. It went for 2 3 minutes, huh? Okay, went for 2 3 minutes. Okay, fine. Okay, everything is safe, right? Okay, we'll start the session. Now, see, in the previous sessions, we are talking about the footing, right? In the previous session, now, column, right? We are talking about the column. And Okay. Now see student, we have discussed about the end conditions and all. Now see, actually there can be means I'm just giving a means I'm just giving the intention. We have taught about the short column with only axial compression, but there be a case with where short column with uniaxial moment also. Sir, I have given you one plan also where it is axially compression, where there is uniaxial moment, where there is biaxial moment. So if I talk about the here, if I talk about the short column, there is a short column, there is a short column with uniaxial moment. There is a short column with uniaxial moment. When I talk about the short column with uniaxial moment, what we have to discuss here is the maximum strain, whatever the maximum strain, whatever the maximum strain, the maximum strain in concrete, the maximum strain in concrete, the maximum strain in concrete at the outermost fiber, the maximum strain in concrete at the outermost fiber, the maximum strain in the concrete at the outermost fiber is usually taken as how much? Is usually taken as 0.0035. Okay, so this is the maximum strain in concrete at the outermost fiber. As you are know, suppose C students, if I consider this is a column and the column is supposed to reinforced here with this, suppose it has reinforced in this way, suppose I'm telling you, and if I consider this as the depth, and the depth is like this is d by 2 and this is d by 2. If I see, okay, now in this case, how the neutral axis will be, see how the strain distribution will discuss. Here, if you talk about the strain distribution will be always linear. So the strain distribution will be somewhere like this. Okay, but if you see in the uniaxial moment or anything, if you see the this is how it will look like the strain distribution 0.003. So here what we have to do, sir, see, when I talk about the strain distribution, here please remember students, the thing is that the strain here also varies linearly and you have to remember the maximum strain is 0.0035. Now see students, this can be the objective question in your exam. There is a curve, sir, in columns. Actually, you should be knowing about the code also, SP16. Sir, in addition to IS 456, students, you should also follow SP16. Agree or not? Sir, are you aware of that code? Are you aware of the code SP16 in addition to IS 456? For columns, there is a code called SP16 also. Okay. So here, when we see the code, there is a curve called interaction curve. Sir, this is the objective question asked so many times in JE and AE. So when I talk about the interaction curve here, okay, this was a graph drawn between ultimate load and ultimate moment. There was a graph drawn between ultimate load and ultimate. What is PU means here? It is a graph is drawn between ultimate load and this one is a graph is drawn between ultimate load and ultimate moment. Here, what I would like to tell you is when a graph is drawn between ultimate load and ultimate moment, what I would like to tell you here is the graph seems to be like this. Okay, here the graph will be like this. The questions asked were, suppose see students, this is zone 1. The questions, what is zone 2? What is zone 3? They can ask you this. Suppose if I take this as A, this is a B, they can ask you like this also. What comes under zone between A and B, what comes under zone between B and C, and what comes under C and D. This is the famous question they have asked. Here I have written it as 1. 1 is the compression failure. Sir, you can ask me, sir, how do you know this graph? How do you say this? This is entirely from Codam. This is SP16. They'll ask you in SP16 graph, if a graph is drawn between ultimate load and ultimate moment, what is zone 1? It is compression failure. And what is 2 is nothing but the 2 is nothing but what, sir? 2 is nothing but the balanced failure. 2 is nothing but the balanced failure. And 3 is nothing but the టెన్షన్ ఫెయిల్యూర్ రే ఆ బట్టలు పైన ఆరబెట్టించు క్లిప్లు ఇచ్చి ఆవిడకి పంపించు థర్డ్ వన్ ఈజ్ దగ్గరుండి చేయించు థర్డ్ వన్ ఈజ్ వాట్ సార్ అయ్యి ఫస్ట్ అవి వేయించరా ఫస్ట్ అది ఈ పైన అవి పెట్టించు థర్డ్ వన్ ఈజ్ నువ్వు మొత్తం క్లాస్ జరగనవు థర్డ్ ఈజ్ వాట్ సార్ టెన్షన్ ఫెయిల్యూర్ దేర్ థర్డ్ వన్ ఈజ్ వాట్ స్టూడెంట్స్ ఇట్ ఈస్ టెన్షన్ ఫెయిల్యూర్ ఫస్ట్ అది వేయించరా First one is compression failure, second one is balancer failure, and third one is tension failure. So here students, they can ask you what is compression failure. The zone between A and B is compression, zone between B and C is tension balance, and zone between C and D is tension failure. Is this clear for everyone? Clear, sir. This is the common question they can ask you. What is zone 1? Zone 1 is compression failure. Zone 2 is balanced failure. Zone 3 is, sir, they will give you the direct graph and also they can ask you these things. Okay, now let us see. Now see students, they can ask you short column with, they can ask you short column with, short column with, short column with biaxial bending. Sir, what do you mean by biaxial bending, students? Can anyone tell me what do you mean by biaxial bending? Can anyone tell me? Short column with biaxial bending. Sir, this thing is the last topic for column and we'll move on to the next topic. Okay. What is short column with? Okay, very good. The bending which is occurring in both the directions, or you can say bending in both directions. Bending, bending in, bending in bending in both directions is known as biaxial bending. Bending in both directions is known as biaxial bending. So here, bending in both direction. Sir, this actually should satisfy one condition. The bending which is happening in both direction, then it should satisfy both. But the grid part killingsra. Here, what I would like to tell you is MUX upon MUX1 whole power alpha n plus MUY upon MUY1 alpha n should not be greater than 1. Should not be greater than 1. What is MUX and MUY? MUX and MUY are the factored moments, factored moments factored moments. MUX and MUY are factored moments along MUX and MUY are the factored moments along X and Y axis. These are the factored moments along X and Y axis. Then if you ask me what is MUX1 and MUY1. Sir, see students, if the condition, if they have taken this condition, if this condition is satisfied only, then only you can analyze. It should satisfy this condition. Then only you say whether the short column which subjected to biaxial bending is safe or not. Okay. MUX1 and MUI1 are the moments capacities. Moment capacity of column. Sir, here it is factored moment. Here it is moment capacity of column. Moment capacity of column along X and Y. అరే క్లిప్పులు పట్టుకెళ్ళావా along X అరే ఆవిడని పెట్టిందే తీసుకెళ్ళడానికి రా ఇవన్నీ చేయించడానికి నువ్వు పాకేదాలో నువ్వు చేయకు along X and Y axis. Sorry students. So here MUX and MUY are what, sir? MUX and MUY are what, sir? Factored moments along X and Y axis. MUX and MUY1 are the factored moments along X and Y axis of the column. Now, sir, actually, my dear students, the famous question asked in this objective, in AE, JE or anything is, they will ask you, the question here is, what factors alpha n depends upon. See students, alpha n is a coefficient for your information. Alpha n is a coefficient. Alpha n is what, sir? Alpha n is a coefficient. Alpha n is a coefficient which depends on alpha n is a coefficient. Alpha n is a coefficient which depends on they can ask you this important number. Which depends on amount of reinforcement, which depends on amount of reinforcement, or it depends upon yield strength of steel. They can ask you which of the following on what factor alpha coefficient depends on biaxial moment. Yield strength of steel. Okay, next. Strength of concrete. One is amount of reinforce. Second one is yield strength of steel. And the third one is strength of concrete. And the other thing we have is the cross-sectional dimension. Other one we have is the cross-sectional. So here, please understand students, what is alpha n is? Alpha n is a coefficient which depends upon the amount of reinforcement, yield strength of steel, strength of concrete, and cross-sectional dimensions. On these factors, the alpha n coefficient depends. Clear, my dear students? This is an objective question, student. Which of the following, on which factors it depends upon? Amount of reinforcement, yield strength of steel, concrete strength, and also it depends upon the cross-sectional dimensions. Fine? Now see students, the columns are slendered. Slender means, sir, if the lateral dimension is very small compared to the length, then there will be more slender. So in this case also, there is an additional moments. Whenever the members are slender, there will be an additional moments due to slenderness of the column. Sir, what is slenderness? Effective length by least lateral dimension. Least lateral dimension. So the additional moment due to slenderness ratio or due to slenderness members, due to slenderness of the column is given. This is also another important thing, students. Students, again and again, I'm telling you, based on the effective conditions, I have told you previous day, both ends fixed, 0.65L, one end fixed, other end hinged, 0.8L, both ends hinged, 1L, one end fixed, other end free, 2L. That is a very, very important question, my dear students. Okay. The additional moment of the additional moment due to slenderness of the column is additional moment in x direction will be given as PD by 2000. This x direction means LEX by the least lateral dimension in the other direction. Sorry, P whole square. Similarly, if it is movement in additional moment in y direction means PB by 2000 into LEY by V whole square. Clear, students? Any doubts in this?
Effective length है sir, LE.
What?
LE effective length.
LE is the effective length in x direction and LE is the effective length in y direction. Okay. So students, now we are going to the next important topic, that is torsion. Next we are going to the important topic, torsion.
Backslide करना sir.
Sir, please be patient. This torsion I am expecting a question on. This torsion I am expecting a question. Okay. Have you written, sir? Now see. Sir, how many of you know what is the difference between torsion and a moment? Anyone? Can you explain me? What is the difference between torsion and a moment? आपको पता है what is moment and what is torsion? What is torsion? And torsion is a twisting moment. Okay. What is bending and what is torsion? Still more, anyone? सर आप एक एग्जाम्पल में दे दिया. सर आप साइकिल में क्रैंक व्हील है ना, पेडलिंग है तो ऐसा ऐसा कर दिया ना, वो सर्कुलर मोशन है, वो टॉर्शन है. वो बीम कैसा बेंड कर दिया, लॉन्गिट्यूडनल है. सपोज आई एम गिविंग यू दिस वन, ए बीम बेंड्स इन दिस वे. Suppose if it is a cylindrical shaft, it tries to twist in this way. Sir, a drilling a nail into the wall is nothing but a torsion. A beam bends. Agree or not, my dear students? Agree or not? Agree? A nail is drilling into a wall and a beam bends. Oh, Ramesh Raja. See, I want to tell you twisting and bending you can name. Okay, fine. Very good, very good, very good, very good, very good answer. So, are you clear, my dear students? The best example for torsion is if you are doing a pedaling a cycle or if you are trying to drill a nail into the wall, all these are torsions. But if you see a bend, a beam bends, that is called as bending. Clear, my dear students? And remember, in mathematically, bending moment follows coordinate geometry and torsion follows polar coordinates. Torsion follows polar coordinates. So let us go into the practicality of the torsion. See, students, what is a torsion is, if the torsion, if I see, if the longitudinal, if you see in a torsion, if the longitudinal axis of a structural member, the longitudinal axis of a structural member, if the longitudinal axis of a structural member and loading axis, the longitudinal axis of a structural member and loading axis and loading axis are, if the longitudinal axis of a structural number and loading axis are perpendicular to each other, and loading axis are perpendicular to each other, and loading axis are perpendicular to each other. The longitudinal axis of a structural number and loading axis are perpendicular to each other. The structural member will be subjected to the structural member will the structural member will be subjected to the structural member will be subjected to what, sir? The structural member will be subjected to twisting. Are you getting or not? If the longitudinal axis of the structure and the loading axis are perpendicular to each other, the structural member will be subjected to twisting. And immediately Rohit will ask me, sir, can you show me an example where we can find this twisting? Sir, can you show me an example where you can find this twisting? Okay, so here, my dear students, if I take a beam like this, a canopy beam, they call it as a canopy beam, and if you apply a load here, this is a beam, this is a slab, and this is a beam. You can say here, there it will be subjected to what, sir? Twisting. This is a canopy beam. Or you can say isolated L beam. Or the best example is grid support. If you see grids, you see the grids here. These will be subjected to what, sir? If you see here the grids will be subjected to torsion. So what are the examples of twisting is, if the longitudinal axis of the structural member and the loading axis are perpendicular to each other, then the structural member will be subjected to twisting. So आपको clear है, sir? Okay. Next. Sir, here we also have to talk about the classification of torsion. Here we also have to talk about the classification of. Here we also we also have to talk about the classification of torsion. Sir, how do we classify the torsion here? The first one we call it as statically determinate. The first one we call it as the statically determinate, statically determinate, statically determinate, statically determinate, or equilibrium torsion, or equilibrium torsion, or primary torsion. So what are the classification of torsions here is? One is the statically determinate torsion, equilibrium torsion, and primary torsion. These are the different types of torsion. So students, all these are same. Sir, when in structure analysis, you might have studied what is a statically determinate structure. Anyone? I would be happy, Amma. What is a statically determinate structure? Sir, if your equilibrium equations are sufficient to solve a problem, then it is a statically determinate structure. Now see the torsion in a car. See, I'll tell you, Amma, what is a statical determinate or equilibrium or primary torsion is, you can say torsion in a torsion in a torsion in a canopy beam, torsion in a canopy beam, which I have showed you, L beam, Okay, or a curved beam. Torsion in a canopy beam or a curved beam in a horizontal plane is the best example of statically determined or equilibrium, or you can say primary torsion. All this is the best. Now, what is actually this one? What is statically determined or equilibrium or primary torsion? A torsion that is required or that is developed to maintain static equilibrium in the structural assembly is known as. Sir, here what I would like to tell you. A torsion that develops what is primary torsion or static or equilibrium torsion is a torsion that is develops to maintain static equilibrium. Immediately you will ask me, sir, how this torsion will maintain static equilibrium? What is this maintaining static equilibrium? Sir, how this torsion maintains static equilibrium is the external load, whatever the external load which is acting on the structure, there is no alternative being resisted. That means the external load is resisted by torsion alone or resisted by torsion. If the external load is resisted, suppose if you are applying a load on a structure, if it is resisted by torsion only, then we can tell it as a statically determined. Okay, clear students? What is a static? What is a statically determined or primary torsion or what is a statically determined or primary or equilibrium torsion is a torsion that develops to maintain static equilibrium. How it will maintain static equilibrium, students? The external load will be resisted only by what, sir? Only by torsion. Students, are you following? Can you quickly respond in the chat box? Are you following? Yes or no, everyone? Is it clear for everyone? Can you please quickly respond, my dear students, all the students? Are you following, Amma? Sir, what I want to tell. Okay, fine. Thank you. So this is the static torsion. Similarly, sir, they can ask you one of the objective question, Amma. Sir, Imran Loni or Vishal Ban, I'll tell you one more thing. They'll ask you, what is the other name of statically determined torsion? You can say it is equilibrium torsion, or you can say it is primary torsion also. You can say equilibrium torsion, or it is also known as primary torsion. The other names also you have to remember. That is the reason I have given, because these kind of objective questions are also asked. Now, see, students, what I would like to tell you, the other torsion we have is statically indeterminate. We can say statically indeterminate, statically indeterminate, statically indeterminate. We can say statically indeterminate or compatibility torsion or compatibility. Statically indeterminate is also known as compatibility torsion, or it is also known as secondary torsion, or it is also known as what, students? This is also known as secondary torsion. Okay, now see, when I talk about statically indeterminate means if the equilibrium equations are out there, if the equilibrium equations are alone or not sufficient to solve the structure, then it is known as statically indeterminate or compatibility or secondary torsion. Sir, what is secondary torsion is? Yes, sir, what is secondary torsion? A torsion, a torsion ఇప్పుడు చెప్పరా ఫస్ట్ అవి క్లీన్ చేయమని రేపు వేరే వాళ్ళు వస్తున్నారని చెప్పు. ఏ టార్షన్ రేపు చేయను. ఏ టార్షన్ what is statically indeterminate or secondary or compatibility torsion? See, a torsion which is arised, a torsion that is arised due to continuity, means you cannot say it is continuous. A torsion that is arised due to continuity is nothing but secondary torsion or compatibility torsion, or you can say statically indeterminate torsion. Sir, see, actually, if you see here, this kind of torsion depends upon statically indeterminate or compatibility or secondary torsion depends upon the stiffness of interconnected members, how the members are stiff and how they are connected. It depends upon the stiffness of interconnected members. Now immediately Rohit will ask me, sir, what are the examples of statically indeterminate or compatibility torsion? Here you told for statically determinate canopy beams, or you told curved beams. Rapid rotation means rapid rotation, we should not say. It is a kind of torsion which they are not balanced. Actually, Asha Vani, there is a continuous rotation in this way, but of not equal magnitude. Okay. See, you can say whatever the torsion which is occurring due to the torsion which occurs due to the torsion occurs due to stiffness of the beam, due to stiffness offered by the beam, due to stiffness offered by the beam, against torsional rotation. Stiffness offered by the beam against torsional rotation. Against the torsional rotation, the stiffness will be offered, means it will not allow to rotate. That is what secondary torsion. Example, you can say grid system, which I have shown you, or edge beam of a frame. You can say edge beam of a frame also is a better example of compatibility torsion or secondary torsion. Edge beam of a frame. These are the examples. See students, examples can be asked. Which of the following will be subjected to primary tension and which of the following will be subjected to secondary torsion? So here you should see, these are the examples. These are the examples here for primary torsion, and these are the examples for secondary torsion. Okay. Now see students, how should be the design approach? Now see students, how should be the design steps? Sir, see, first thing. Now tell me, sir, due to torsion, first thing, I'll tell you one thing, Amma. Due to torsion, you have to design for, I'm telling you simple steps. Due to torsion, you have to design for additional shear. Due to torsion, you have to design for additional shear. Due to torsion, you have to design for additional shear and also additional moment. Due to torsion, you have to do for additional shear or additional moment. Due to torsion, you have to design for additional shear or you have to design for additional moment. In this case, what will be the equivalent shear is, sir, this can be a direct question in your exam. Amma. What is the, due to torsion, what is the equivalent shear? The equivalent shear will be equal to 1 Vu plus 1.6 into Tu by B. This is the formula which you knows very, very well. Okay. Now, how do you calculate the nominal shear stress, sir? How do you calculate the nominal shear stress? Can anyone tell me? How do you calculate? Nominal shear stress, if I, or you can write nominal means here it will come as, I told you due to torsion you have to design for additional shear and additional moment. So nominal shear will be designed for, nominal shear stress will be equal to tau VE is equal to what, sir? This I'll substitute, this is VE if I write equivalent shear or VE by BD. Are they okay? See, and tau VE should never exceed tau C max, which I have told you in shear. Tau C max means it is the, which is the check for diagonal compression, and it is a function of grade of concrete only. Okay. Now see, suppose if tau V is less than tau C, if tau V is less than tau C, you should design for minimum reinforcement. You should design for minimum shear reinforcement. That is already you know, minimum shear reinforcement. That is ASV upon B into SV is equal to 0.4 upon 0.87 Fy. This is the formula. Sir, you can understand. Sir, what is the difference between shear and here means? ASV will increase or SV will decrease. Okay, sir. So these things you should remember. Now suppose if tau V is greater than tau C, not tau C max, if tau V is greater than tau C, in this case you have to design for both longitudinal reinforcement, you have to provide both longitudinal reinforcement and transverse reinforcement, or transverse means both horizontal reinforcement as well as vertical reinforcement. Okay, reinforcement should be provided in this way like this. If tau V is greater than tau C, we should provide longitudinal and transverse reinforcement. Then immediately you will ask me, sir, how to provide this reinforcement? That is the question you will ask me. Yes or no? That is the question you will be asking me. Now see students, when I discuss here what is longitudinal reinforcement, what is longitudinal reinforcement? When I talk here, what do you mean by longitudinal reinforcement? When I talk about longitudinal reinforcement here, see here, we should talk about the equivalent moment first thing. What is equivalent moment is equal to what is mu students? Equivalent moment is equal to ultimate moment. Okay, long mu is equal to mu is equal to what, sir? Mu is equal to ultimate moment. mu is equal to what, sir? Ultimate moment plus mt. Amma, this formula, sir, please remember this formula is very, very important. And if this is also important, sir, they can ask you what is the moment due to torsion. Anyone? Can anyone tell me what is the formula for moment due to torsion? I would be very happy. What is the moment due to torsion formula? Sir, moment due to torsion. If Tu is the torsional moment, Tu into 1 plus d by b upon 1.7. This is the formula for moment due to torsion. Sir, here please see here D, capital D I have shown you. So it is a overall depth. Here D is important. D is not effective depth and D is overall depth. Okay. Now see students, suppose you are telling here, here equivalent moment is equal to what? Ultimate moment plus moment due to torsion. See students, here I have a question, important question, Amma. These questions you should be very careful. When I am solving this, I will ask you these things. If moment due to torsion, if moment due to torsion, this point, if moment due to torsion is greater than the ultimate moment due to torsion is greater than ultimate moment. In this case, longitudinal compression reinforcement. Sir, when we solve the problem, you will get all the questions. Okay, please give me some time. Longitudinal compression reinforcement shall be provided on flexural compression phase. These will be provided on what, sir? These will be provided on flexural compression phase. These will be provided on flexural compression phase. Okay. Here, how do you calculate equivalent moment is, you will be designing the flexural compression, longitudinal compression reinforcement. ME2 is equal to moment due to torsion minus ultimate moment, because moment due to torsion is greater than MU. Okay, you will be designing for this only. Remember students, here in case of longitudinal reinforcement, you will design for equivalent moment, that is Mu plus Mt. If suppose moment due to torsion is greater than ultimate moment, you will be designing for moment due to torsion minus Mu, because you already provide the minimum shear reinforcement. The reason for this is you already provide the minimum shear reinforcement. Now, my dear students, if you see when you talk about the transverse reinforcement, when I talk about the transverse reinforcement, when I talk about the transverse reinforcement, here, you should understand that here, sir, some people will tell you in different formulas, but I will tell you very easy formula. The formula is 0.87 Fy ASV into D upon SV should be equal to Tu by B1 plus Vu upon 2.5. This is very important. This you have to remember. And you can also remember ASV is equal to tau V minus tau C into BSV into 0.87 Fy. So in both the cases, you will find ASV, and whichever is more, you will be taking this as your transverse reinforcement. Now immediately your friends will ask me, sir, have you written this? Can I move on to the next slide? We'll solve one problem among this. Then you'll.
इसमें सर मोर वाला देखेंगे जो है
दोनों में क्या ज्यादा है तो वो लेके आता. Sir, steel jada means dono are check for transfer. Actually, there are two reinforcement. One, you provide the main longitudinal. and other you provide the transverse. So in transverse we have two formulas for ASV. उसमें क्या ज्यादा है तो वो लेके आता. Vishal Ban, have you written, sir? Now immediately your friends will ask me what is B1, what is B1 and D1, they will ask me now. You can write here D1 number. You will ask me what is B1 and D1. Okay. Now see, sir. Suppose if I talk about SV here. SV is the spacing of stirrups. SV is nothing but the spacing of stirrups. SV is known as the spacing of the stirrups.
Sir, in ME2, what is small t? You have written small t.
This is moment due to torsion, amma. MT is known as.
Sir, in ME2.
Wherever this is also capital T or small t, both are same, sir. Moment due to torsion. Okay. Now, what is tau V is equivalent shear stress. What is B1? What is B1, sir? What is B1, sir? B1 is the center to center distance between bars, center to center distance between bars in the direction of width. See, students, actually I will show you one thing. Suppose if you consider a column like this, a column or whatever, if you consider a stirrup here, means you consider a bar like this. So what is B1 is the center to center distance between bars in the direction of width. So this distance is known as B1. Now if you have here, okay, now what is D1 means? D1, if I have in the this distance, you can say here, this distance is, this is B1, this is D1. D1 is the center to center distance between bars. D1 is the D1 is the center to center distance between bars. Center to center distance between bars. Center to center distance between bars. In the direction of center to center distance between the bars in the direction of depth. Liza Lehmanra, in the direction of depth. What is D1? D1 is the center to center distance between the bars in the direction of depth, and B1 is the center to center distance between the bars in the direction of width. Okay. Now see, students, I will give you one question, Amma. I want everyone to solve this problem. It is not like I will explain you and you will be done. Okay, I want you to solve everyone to this problem. An RCC beam of size, an RCC beam of size 300 into 1000 mm. An RCC beam of size 300 into 1000 mm is subjected to a shear force of 150 kilonewton. Moment is 150 kilonewton meter and torque is 30 kilonewton meter. Okay. Calculate equivalent bending moment. Calculate equivalent bending moment and equivalent shear. I would be very happy if you solve this problem. I'll give you 2 minutes of time and you have to solve this. Calculate the equivalent bending moment and calculate the equivalent bending moment and equivalent shear force. Calculate the equivalent bending moment and equivalent shear force. Please solve that problem. Sir, I'll give you 2 minute break and I'll join in 2 minutes. Meanwhile, please solve that problem. Sir, please don't go away. These problems are very, very important. Don't leave the session. I'll be back in 2 minutes. Done, sir? Okay, students will see the answer. Here the equivalent shear is equal to what, sir? VU plus 1.6 into TU by B. This is nothing but the equivalent shear. So what is equivalent shear is, here it is equal to 150 plus torsion is how much? 30. So 1.6 into 30 divided by, sir, see please my dear students, the units are kilonewton meter. Here it is B, not D. So B is equal to how much, sir? 300 mm means 0.3 meter. So this will be equal to 150 plus 0.3 into 100, 100 into 1.6, 160. So this will be equal to 310 kilonewton. How many have written 310 kilonewton? 1 second. 310 Simran, correct. Shobhan Sunud, correct, sir. Correct. Very good, Amma. Very good. V is 310. Now, equivalent moment is equal to ultimate moment plus moment due to torsion. So, first I'll calculate moment due to torsion. What is the moment due to torsion, my dear students? What is the moment due to torsion formula? The moment due to torsion formula is simple. Here it is Tu into 1 plus D by B upon 1.7. So what is Tu? 30 into 1 plus D is 1000 mm. You can write 1000 directly because it is a ratio. B is 300 mm upon 1.7. So 30 into 4.33. 3.33, 4.33. You will get around this value. How much, sir? Anyone, can you tell me what is this value? This will be equal to around 76.5 kilonewton meter. Now, what will be the equivalent moment? Equivalent moment is equal to ultimate moment plus moment due to torsion. It is equal to ultimate moment plus moment due to torsion. Ultimate moment is 150 and moment due to torsion is 76.5. And this will be equal to, equivalent moment is equal to how much, sir? 226.5 kilonewton meter. 226.5 kilonewton. Clear, students? Any doubts in this problem? Clear, sir? Clear. Okay, okay. Correct, correct. Everyone. I hope you are clear. Now, see, students, I have a question for you for the next problem. Is it clear for everyone, my dear students? Can I move on to the next problem? Okay. The next problem is an RC beam of size. An RCC beam of size. An RCC beam of size 300 into 600 mm. 300 into 600 mm is subjected to 300 into 600 mm is subjected to a factored values of is subjected to a factored values of shear force, 100 kilonewton is subjected to factored values of shear force 100 kilonewton and bending moment of 100 kilonewton meter and bending moment of 100 kilonewton meter and twisting moment of 34 kilonewton meter and twisting moment of 34 kilonewton meter. The longitudinal tension reinforcement will be designed for. The longitudinal tension reinforcement will be designed for. the longitudinal tension reinforcement will be designed for the longitudinal tension reinforcement will be designed for. Please solve this problem, Amma. Designed for a moment, you can write. Longitudinal tension reinforcement will be designed for a moment of. Please solve this problem, students. I'll give you 2 minutes of time. Okay, let me explain. Sir, see, what is the torsional moment here? Moment due to torsion. Moment due to torsion is, what is moment due to torsion, Amma? What is the moment due to torsion? The moment due to torsion is given by Tu into 1 plus d by b upon 1.7. So here equivalent moment due to torsion is equal to, what is twisting moment? 34 plus 1 plus 600 by 300 upon 1.7. So this is 20. 20 into 4 is how much, sir? 20 into 4 is how much? 80 kilonewton meter or not? Is it 80 kilonewton meter, students? Yes or no, Amma? $30. Sir, 34, 20. 20 into 600 by 300. 2, 3 into 20. Sorry, 60, I think. Sorry, it is 60. Yes, it is 60, right? Sorry, sir. Now tell me, sir, it will be designed for what? Longitudinal tension reinforcement will be designed for what? Longitudinal design reinforcement. Here you have to calculate equivalent moment. Equivalent moment is equal to what, my dear students? Equivalent moment is equal to what? Mu plus Mt. The longitudinal reinforcement is Mt greater than Mu? No, Mt is less than Mu. So it will be designed for Me, that is equal to 100 plus 60. That will be equal to 160 kilonewton meter. So here you will be designing for longitudinal tension reinforcement will be designed for 60 or 100 or 160, students. Can you tell me? Sir, I'm 160, sir. Very good. Tanveer, Vishal Ban, 160, not 60, Amma. Moment due to torsion is 60. I agreed completely. But longitudinal tension reinforcement, sir, see, when I tell you one statement, I've told you one statement, Amma. Sir, due to torsion, you will be designed for additional shear and additional moment. That means you always here design for equivalent moment. So here it is. Here it is. What is the answer? You will be designing for ME. You can write here. That is equal to 160 kilonewton meter. Okay. Clear, students? Clear, Amma? Yes. Okay. Now, if this same problem, sir, the same problem, torsion is taken as 68 kilonewton meter, the longitudinal Then longitudinal compression steel. Then longitudinal compression steel. The longitudinal compression steel will be designed for. The longitudinal compression steel will be designed for. Can anyone tell me this? The longitudinal compression steel will be designed for. Sir, whatever you have studied here, same thing. Ultimate moment is 100 kilonewton meter. Section is 300 into 600. Now solve the problem. I'll give you 1 minute of time. Very good, sir. Very good, Vishalman. Very good. Now see, students, here in this problem. Thank you. Now the solution here is moment due to torsion. Moment due to torsion is given by the formula Tu into 1 plus d by b upon 1.7. So this will be equal to how much, sir? Here torsion is 68 into 1 plus d by b. What is d? 600. And what is b is 300 upon 1.7. So moment due to torsion is how much, sir? This is 40 into 3, 120 kilonewton meter. Now, see, students, here he is asking for compression steel. So the moment due to torsion is greater than mu. That is 120 is greater than 100. So the compression steel will be calculated for equivalent moment, that is mt minus mu. That is equal to 120 minus 100. So you can write here 20 kilonewton meter. You can write here 20 kilonewton meter. Any doubts in this, students? Very good, sir. Very good. Very good. Moin Mustaq. Everyone, is it clear, Amma? Sir, now my intention is clear for you, right? Okay. Now, last problem I'll give you, Amma. Another problem I will. This is IES kind of question, but simple question. A reinforced concrete beam or RCC beam. RCC beam. An RCC beam of 10 meter. An RCC beam of 10 meter. Effective span. An RCC beam of 10 meter. Effective span. An RCC beam of 10 meter effective span and 1 meter effective depth and 1 meter effective depth and 1 meter effective depth is simply supported. The total UDL on beam is 10 mega Newton meter. The design shear force of the beam is I'll give you 2 minutes of 1 minute of time now. Please solve this. The design shear force of the beam. I'll give you 1 minute of time. చాలా పడ్డాను మరి. మరి నువ్వు నీకు చెప్పింది చేయగల అంతా పెద్ద. The design shear force of beam. రికార్డ్ అవుతుంది అది. 1 second back, please, sir.
Yes, Lord.
Solve this problem, students.
Happy. క్లీన్ చేయరా లేకపోతే పడతాయి టాబ్లెట్ తీసుకుగలుగుతా
ఈ రాని వచ్చినప్పుడు జాగ్రత్త దాసి ఇవి వాడు అని చెప్తాను. కరెక్ట్గా సెట్ అవుతుంది. సరే. Have you done the problem, students? So see here, simple problem. Sir, see, this is a 10 meter, right? And he is asking 10 mega Newton meter. Sir, see. And effective depth is 1 meter. Okay. What will be the total force, Amma? What will be the total force? What will be the total force? What will be the total shear force? Can anyone tell me? What will be the total shear force? It is 100 kilonewton. Okay. Total shear force is 100 kilonewton. Sorry, not 100 kilonewton, sir. It is 100 meganewton. Now see, students. See here, I would like to tell you one important. This is 100 meganewton. This is 100 meganewton. What will be the bending moment, Amma? What will be the bending moment here? It will be equal to WL square by 8, right? That is equal to how much, sir? 10 into 10 divided, sorry, 10 square upon 8. 10 meter and 10 kilonewton, meganewton per meter. This will be equal to how much? Can anyone tell me? This will be 125 meganewton meter. Yes or no? Yes, sir. Now see students, total force is 100 meganewton. So here, sorry, here I have written wrong. Here actually reactions will be how much, sir? It will be half. This is 50 meganewton. This is 50. Okay. Now, see students, what he has asked here. He has asked us the, can anyone tell me what he has asked in this problem? He is asking the design shear force. So what will be the design shear force? Anyone? How will be the design moment, sir? It will be in this way. Yes or no? In the bending moment diagram. Yes or no, sir? Now he is asking what we have to design for. So here when I talk about what we have to design here is asking the design shear force. So when I talk about the design shear force here what you can say? What is the answer? Can anyone tell me? I'll give you another 1 minute. Students, I'll give you another 1 minute. Please try this problem. Sir, these kind of problems you have to solve. Okay. If you solve these kind of problems, anyhow, this will be very easy. Okay. Very good, sir. Very good. WL by 2. That is nothing but 50 meganewton. Sir, if they give you column and everything, they can. Sir, actually, in this they have to give the column size and all. Then it, in that case, it will vary. Okay. 50. Very good, sir. Very good. Very good. The answer is 50 meganewton. Clear, my dear students? Now, sir, see, here I'll talk. I hope you are clear until now. Can I move on, Amma? Can I move on? Is it clear for everyone? Can you quickly respond? Next one. Sir, next point I would like to discuss here is the, sir, this is very, very important. Amma. What I am like to discuss here is the side face reinforcement. Next point I would like to discuss here is the side face reinforcement. Sir, usually when do you go with side face reinforcement in an ordinary beam? You go when the depth of the beam exceeds 750 mm. So here this is a very important. In case of torsion, you should write very, very important amount. In case of torsion, in case of torsion, when depth of the beam, very, very important, sir. When depth of the beam exceeds 450 mm only. Sir, very, very important question. This can be an objective. But in case of torsion, when there is no torsion, when it is exceeds 750 mm, it will. How much it will be provided means 0.1 percentile of gross area. 0.1 percentile of gross area. Clear, students of web? పెట్టు మళ్ళీ 0.1% of gross area. Careful. 0.1% of gross area. Okay. Now see students, here when I talk about spacing, when I talk about the spacing, when I talk about the maximum spacing of, when I talk about the maximum spacing of shear stirrups, okay, it should not be greater than x1. It should not be greater than x1 plus y1 by 4, or it should not be greater than 300 mm. What is x1 and y1, you will ask me. You can say x1 is the shorter dimension of stirrup, and y1 is the longer dimension of stirrup. Agree, students? X1 is the shorter dimension of stirrup, y1 is the longer dimension of stirrup. X1 is the shorter dimension of stirrup, and longer dimension of stirrup. Okay. Now see students, we will solve some objective questions in this chapter. I hope you are clear. Now see students, this question I would like to ask you. Torsional effect is significant in case of, I would be very happy. Significant means it is more, is significant. In the case of, I will give you options. First one, lintel, T-beam, cantilever beam, and also L-beam. Torsional effect will be significant in case of what, sir? Lintel, T-beam, cantilever, and L-beam. What is the answer? Sir, I'm very good, Simran. Very good. L-beam is the correct answer. Because I told you clearly what is the example of statistical compression, canopy beams or curved beam, or I told you it is an L-beam. I told you, please see here, Aman. Did I told you L-beam? Yes. Next. I have told you clearly, L-beam. Very good. Next. Primary torsion or statistical determinate torsion. Primary torsion.
Sir, why it is T and L beam?
Sir, torsional effect
Since the
C.
direction of force is
Yes. Yes. Sir, you can ask me why it is not there in the T-beam. but he has used the word cantilever beam. He has used the word significant. Significant. That is the reason it is more significant in L beam. If he has not used
Okay,
the
okay,
word
okay.
significant, then it is okay. You can say cantilever also. Agree? Agree, sir?
Agreed, sir. Agreed.
Okay. Next, primary torsion occurs in. Sir, see here. Primary torsion occurs. Primary torsion occurs. It occurs in simply supported beam, but laterally restrained beam. But it occurs in simply supported beam, but laterally restrained means what, sir? What do you mean by restrained? Can anyone tell me? Laterally restrained, subjected to eccentrical loading. Laterally restrained means is not allowed to move. Okay. Laterally restrained means you can say it is not allowed to move. Okay. Now this is another important question, Amma. I would like to tell you, very important. Ring beam of a water tank. Ring beam. Pulomane hatto. Ring
Backside
beam
में
of a water tank will be designed for. Ring beam of a water tank is designed for. A bite teacher todra. Ring beam of a water tank is designed for. Radhikadra. Ring beam of a water tank. Now see students, the ring beam of a water tank is designed for what? Can anyone tell me the ring beam of a water tank is designed for? I would be happy if anyone tell me, sir. Sir, Ramesh Raza, I will agree. Is it designed for primary torsion or secondary torsion?
सर ये eccentric loading है lateral
Yes, sir. Yes,
restraint
sir. Sir, if there is no eccentrical loading, actually movement won't be there, Amma. Actually, if you consider a symmetric loading, here the load will be something like this. Then only it will be subjected to tension. If you consider a simply supported beam, it will be subjected to a transverse load like this. Then if you see here, it will be subjected to torsion like this. Are you getting me, sir? Okay. Now see, sir, you can say here, a ring beam of a water tank is subjected to what, sir? It's subjected to what? It's subjected to equilibrium torsion. Is subjected to what, sir? Is subjected to equilibrium torsion. This is subjected to what, sir? This is subjected to equilibrium torsion. Now, what is equilibrium torsion, sir? What is equilibrium torsion? I explained you. Sir, if the longitudinal axis of a structural member is perpendicular to each other, then the structure will be subjected to twisting. That is called torsion. Sir, what is equilibrium torsion means? If the load has to be resisted by only by the moment, then we have to say it is a circular word. Sir, see, suppose if you have a circular water tank, here you will be applying a load. Whatever the load which is acting on the periphery, it has to be taken care only by torsion. Then that is the reason ring beam is subjected to equilibrium torsion. Clear, sir? Clear, my dear students? Can you quickly respond? Whatever the load which is acting on the circular tank, it is resisted by only by the torsion. Very good, very good, very good, sir. Sir, canopy beams will be subjected to. If you see, canopy beams will be subjected to what, sir? Canopy beams are also subjected to same equilibrium torsion. PRY was primary torsion. Okay, good, sir. Good, good. Now, I have another question for you. What is the minimum number of torsional? What is the minimum number of torsional longitudinal reinforcement? What is the minimum number of torsional longitudinal reinforcement? What is the minimum number of longitudinal torsional reinforcement? What is the minimum number of longitudinal torsional reinforcement? Is here also it is 4. Here also it is what, sir? 4. Next one I would like to tell you. Transverse torsional reinforcement. Can anyone tell me, Amma? Transverse torsional reinforcement is provided by vertical stirrups. Sir, actually one of your friend like Ramiz Raza has told me there was an earthquake in the morning, right? Actually, if you see here, students, actually, if you see the stirrups, you will bend like this, right? If you see in a stirrup, they will bend in this way. Means, actually, if you see the stirrup, students, in case of earthquakes, this is what they should do this, which is required a skill level. And remember one more thing, students, inclined stirrups will become ineffective. They will not be effective. They will be ineffective in case of earthquakes. Are you getting me, sir? Yes, yes. Inclined stirrups will become ineffective in case of what, sir? In case of yes, yes, sir. Yes, Ashavan. Sir, remember, inclined stirrups will be ineffective in case of an earthquake. In case of an earthquake, the inclined stirrups will be ineffective. Next. Sir, the crack pattern due to torsion will be. What is the crack pattern due to torsion? If anyone asks you, how will be the crack patterns due to torsion? How is the crack patterns due to? How is the crack patterns due to torsion? The crack patterns due to torsion is always vertical. The crack pattern due to torsion is always vertical. Agree, students? Is it clear for everyone? Now see, students, sufficient for today. No. Last one. Ashavani, last one. Okay, we'll discuss last one. Even I am very lazy, sir, to take longer duration. I usually don't take, but still I want to take. Let me complete this point and I will end. Ashavani. We have torsional analysis. We have shear stress analysis. We have limit state. We have is working stress. Water limit state, and next one is working stress. So here when I talk about this, sir, torsional analysis will talk about skew bending theory, or torsional analysis is based on skew bending theory. What, sir? Torsional analysis is based on skew bending theory. Now I have a question for you, students. Now I have a question for you. What do you mean by skew bending theory? Anyone, students? What do you mean by skew bending theory? Dear sir, what do you mean by skew bending theory? Sir, usually, see, when you see the combined effect of bending moment, shear, under torsion, we usually talk about this skew bending theory, or in case of and when I talk about the shear stress, when I talk about the shear stress analysis, if you talk about the shear stress analysis, it is due to truss analogy. When I talk about the limit state, it is due to, it is semi-parabolic, or you can read rectangular parabolic, semi-parabolic, or because in the options they have given semi-parabolic, or if you talk about working stress, it is deterministic approach because it will be linear throughout. Are you getting me, sir? So in truss analogy, sir, these are the things you have to follow.
ये इनके ऊपर बेस्ड है सर.
Sir,
जैसे टॉर्जन एनालिसिस बेस्ड है स्क्यू बेंडिंग थ्योरी के ऊपर.
sir, actually, Tanvir, Rohit, please wait. Tanvir, usually the cracks due to torsion will be vertical, amma. In some cases, see, when you see general, I'm telling, it is not like all the case. It is not every time like that only. But in most of the cases, the cracks due to torsion will be vertical. Okay. Or usually they can be inclined also, but we say general it is vertical. Okay, clear,
सर ये
sir?
सर ये 4 पॉइंट्स लिखा हुआ है, ये क्या चीज है?
What, sir?
ये जो 4 पॉइंट्स लिखा हुआ है, ये जैसे टॉर्जन एनालिसिस बेस्ड है स्क्यू बेंडिंग थ्योरी के ऊपर, ये सभी बेस्ड है जैसे
Is
shear
it
stress.
option are given in exam? Then also Tanvir, then also we should go with vertically only. Okay, Tanvir, if both option is given, then we have to go with vertically only. Sir, Rohit, can you tell me what is your thing? Sir, here Rohit, sorry, actually I forgot. Here skew bending theory is what, sir? When it is subjected to both shear and bending moment, then we follow skew bending theory. Shear stress means this is what you do in truss analogy. In sum of the forces are zero. And limit state means semi-parabolic, and working stress means deterministic approach. Okay. Sir Rohit, did I answer your question? You are asking something. Rohit, it depends upon both shear as well as, I want to tell you, torsion depends upon both shear and moment. That is the reason. Okay, with this we are done for the day, sir. Sir, students, are you clear in understanding the concepts? Can you please respond in the chat box of the torsion? Are you clear, sir? Sir, when I tell you important, please follow. Take it as very important, sir. What about remaining students? Can you please respond? Is this clear for everyone? Whatever we have discussed until now. Sir, remaining students also please respond now. When you respond in the thing only, I can get what things you want to get best. Okay. Thank you, sir. I hope you have enjoyed. No, no. Daily 6:30 only students. Actually, today I'll check with madam and I will let you know. Okay. Okay. Thank you, everyone. Thank you, sir. And please prepare well for the exam. Thank you. Okay, sir. With this, we are done. Thank you.